Let's do laws of motion. ठीक है, so we have discussed 3 laws of motion are there. So laws of motion से पहले एक बार पहले force का ले लेते हैं. Force you know is push or pull. Now to describe a force, which two things are required? Anyone?
Mass and acceleration.
Mass and acceleration. Okay, I want to describe force, है ना. So force को describe करने के लिए mass and acceleration is not required. Force को calculate करने के लिए mass and acceleration is required. हाँ जी,
magnitude and
Magnitude
direction.
and direction.
magnitude and direction. ठीक है. So to describe force, you will say force. सर मैंने फोर्स लगाया था हाथी पर, वो मूव नहीं किया. बट आई नीड टू नो ना, आपने कितना फोर्स लगाया, किस डायरेक्शन में लगाया. आपने जो है 2 न्यूटन का फोर्स लगाया या फिर 2000 न्यूटन का. आपने उसको पीछे से फोर्स लगाया या फिर ऊपर से नीचे की तरफ फोर्स लगाया, है ना. सो ऑल दिस आर रिक्वायर्ड टू मेक आउट वेदर द फोर्स वाज इफेक्टिव और नॉट. सो यू नीड मैग्नीट्यूड एंड डायरेक्शन. ठीक है, इट इज द डायरेक्शन which makes it a vector quantity. So force is a vector quantity, right? Force जो है बेटा 2 types are there which we have discussed. बिल्कुल बेसिक में कौन से 2 टाइप के फोर्स होंगे?
Balanced and unbalanced.
बैलेंस्ड एंड अनबैलेंस्ड फोर्स. ठीक है, ये बैलेंस्ड एंड अनबैलेंस्ड फोर्स बहुत इंपॉर्टेंट है. एंड अनबैलेंस्ड फोर्स
Contact force.
नहीं, सिर्फ इन 2 के बारे में बात करेंगे. ठीक है, क्वेश्चन में व्हेन इट सेज अ फोर्स ऑफ 40 न्यूटन इज अप्लाइड, है ना. 9th में क्वेश्चन में बस यही लैंग्वेज होती है. सो you assume it by yourself that the force of 40 newton, just 1 minute beta. So you'll have to assume it, this force of 40 newton is an unbalanced force, right? So this is unbalanced force is there. Okay, so you'll say force of 40 newtons of unbalanced force is applied on the object. ठीक है, आगे जब भी हम डिस्कस करेंगे, so don't take force as only force but an unbalanced force is what you will assume it. Okay, what's the new unit for force? You know it's Newton, right? 1 Newton जो है उसकी यूनिट और बताओ कौन सी क्या यूनिट हो सकती है?
kg meter per second square.
Square.
So this is kg meter per second square. This is mass and this is for acceleration, right? This is your SI unit is there. If I'm interested in CGS unit, what is CGS unit for force? Dyne. So ठीक है, अगर आपको कन्वर्जन चाहिए तो आप केजी को जो है ग्राम से कन्वर्ट करेंगे 1000 ग्राम, मीटर को सेंटीमीटर में कन्वर्ट करेंगे 100 सेंटीमीटर एंड सेकंड स्क्वायर. So this is equals to 10 raised to power 5 dyne is 1 Newton. राइट. चलो, न्यूटन्स के जो 3 लॉज हैं, ठीक है, वो 3 लॉज अगर आप इफ यू आर डिवाइडिंग इट, सो फर्स्ट लॉ, व्हाट डज फर्स्ट लॉ सेज? बिल्कुल लेमन टर्म में.
इनर्शिया मतलब एक ऑब्जेक्ट अगर मोशन में तो मोशन में ही रहेगी और रेस्ट में तो रेस्ट में रहेगी जब तक
इन
एक
टर्म्स ऑफ एक्सेलरेशन.
Acceleration 0.
हाँ, फर्स्ट लॉ डील्स विद व्हेन एक्सेलरेशन इज 0. ठीक है, सेकंड लॉ डील्स व्हेन देयर इज सम एक्सेलरेशन इज देयर. ठीक है, सम एक्सेलरेशन इज देयर. एंड थर्ड लॉ इज रिलेटेड टू मोमेंटम. ठीक है, जो फर्स्ट लॉ है दैट सेज इफ force applied is 0 then acceleration is 0. ठीक है, and second law says that if force is not 0 then acceleration is force upon mass. Object will accelerate. Object कब accelerate करेगा? When there is a unbalanced force is applied on the object. ठीक है, and here the momentum it says 2 ways you can see, है ना. We'll discuss it in detail. One is for each and every action there is equal and opposite reaction. ठीक है, or if you are applying force on someone then that particular thing will apply a force back on you. ठीक है, other thing is momentum is conserved. Momentum is nothing but mass into velocity is conserved. ठीक है. For full universe, mass into velocity is conserved. You cannot increase this or decrease this, right? Agar if let's say you are running on a boat, अगर आप बोट पर बेटा इस तरफ रन कर रहे हैं, then that boat will start moving in this direction so that the momentum of this full system is conserved. This system can be a small system, can be a big system, can be full universe. So full universe में if you ask me what is conserved, I'll say it's mass into velocity or momentum is conserved. ठीक है. So we'll first take this first law of motion. ठीक है. आपने जो definition बोली थी वो बिल्कुल correct थी. First law of motion is dealing with when acceleration is zero. It's not dealing when a thing is at rest. No, it's dealing when its velocity is not changing. Okay, so full chapter is all about motion. Things are moving, so वो जो movement है उनसे related, मतलब this movement are governed by laws, है ना? These are governed by physics numericals और physics formulas. तो वो जो formulas हैं, उन formulas का base जो है वो न्यूटन के 3 laws है. आगे जाकर जो है 11th में you will read other things in detail. So first law says that a body at rest or in uniform motion. So in both the cases, acceleration is zero. ठीक है. In straight line will continue to remain at rest or in uniform motion in same direction. है ना. ये जो same direction word है ये बहुत important है. नहीं लिखेंगे you will lose the marks. Unless an external unbalanced force is applied. Right? Okay. Can anyone tell this definition in some other words where the word acceleration is used? हाँ जी, anyone? आपको word acceleration और deceleration use करते हुए definition बनानी है. ठीक है. It says a body at rest or in uniform motion will remain at rest or in uniform motion. That means that body velocity is not going to change. That means that body acceleration will remain zero, right? So we can say an object will not accelerate or decelerate until and unless some external unbalanced force is applied on it. So जब तक उस body के ऊपर external unbalanced force apply नहीं होगा, it will not accelerate or decelerate. Its velocity will not change, or a body at rest remains at rest. A body in uniform motion remains in uniform motion. ठीक है. So इतना जो हमने बड़ी चीज बोली है, इसको ब्रेक डाउन अगर हम ना करें, है ना, so we can say that a body will not accelerate until an unbalanced, okay, इस सब की जरूरत नहीं है ना. That's it. So ये जो full data है, इस data को we could replace with this. ठीक है. In line को we can just replace it. A body will not accelerate. ठीक है. End of story. Not accelerate means at rest will remain at rest. In uniform motion will remain in uniform motion. Direction is also included in acceleration. If a body direction changes, then it's accelerating. So everything is accounted in this 4 words. हाँ जी, क्लियर है बेटा ये पार्ट?
Yes, sir.
Okay, let's move ahead. So first law just simply says, ठीक है, फर्स्ट लॉ जब न्यूटन ने जो है ना when it gave this laws, उससे पहले जो है ना उनकी कुछ और ही खिचड़ी पकड़ी थी. They were saying कि everything, you know, it's like say when planets are moving around sun, they are saying कि some, you know, external hand is there or God factor is there which is pushing the planets to move around. And they had this thing कि it's if something is moving then it definitely has to stop until unless some force is acting on it. तो वो कुछ और ही वे में देख रहे थे, है ना. क्योंकि वो जो प्रैक्टिकली देख रहे थे उस हिसाब से they were thinking कि बॉल फेंकी वो थोड़ी दूर जाकर रुक गई अपने आप. But then Newton came out with force of friction, and then he changed the concepts upside down, and it says no force, no change in velocity. ठीक है? Anything moving in space will keep on moving. It will not need any energy or any fuel until unless some force is applied on it. Okay. So what will happen next if the boy will pull the sheet with force? So this particular utensils, right, they are at rest, they will remain at rest. This piece of cloth will just come out, right? Only thing required related to this piece of sheet is, anyone? What's required? Will this happen with everything? If I'll keep a towel and put these
Sir,
utensils?
if
Hanji?
the force is applied in a less amount of time.
Okay, we need to apply the force in less amount of time, or we have to give it basically a jerk. आप slowly pull करेंगे, utensils will also fall down. Plus, one more thing is required for this to work.
Sir, smoothness.
Smoothness.
Sir,
The sheet,
inertia.
beta inertia is there already. So basically the smoothness is required. ये जो sheet है ना, this sheet should be जितनी smooth होगी, जितना friction कम होगा, उतना ही ये magic और ये trick work करेगी. Other thing is you need more inertia, what you are saying. So more inertia means you need more mass. More mass means instead of keeping an empty glass, keep a filled glass, right? There is more chances it will stay there. Okay, so what will happen if this motorcycle will hit this? Now what will happen if motorcycle is hitting the barrier? Motorcycle is coming to rest, but the person who is sitting on top of motorcycle, he is not experiencing that force, right? So he was moving ahead, so he will keep on moving ahead. It's the motorcycle which will stay back. Okay, that's what is Newton's first law of motion. Anything at rest will remain at rest, or in motion will remain in motion. Okay, question. So does this Newton's first law is applicable on planets, circulatory motion? Can we say a planet moving in circular motion will keep on moving in circular motion until unless some force is applied on it? है ना? हाँ जी बोलो आदित्य.
No, sir, it will not apply because it will move in a tangent direction, not in a circular direction.
तो अर्थ तो लेकिन मूव कर रही है सर्कुलर में and
This is
continuously.
because of the gravitational pull of the sun.
Okay, very good. So Aditya is saying ki, sir, it's not like there is no force acting on the earth. It's the gravitational pull of sun which is acting on the earth, and that's why it's moving in a circular direction around the sun, right? So this Newton's first law of motion is not applicable for circular motion because it talks about movement in same direction. If direction is changing, then Newton's first law, there is some external force then must be acting on the object. So does Newton's first law apply on rotatory motion? A spinner will keep on spinning until some force is applied on it. Is it true?
No, sir.
No, sir, उसकी direction continuous change हो रही है.
Very good. ठीक है, this is applicable on rotatory motion. ठीक है, rotatory motion में object जो है overall object direction is not changing. Anything which is rotating will keep on rotating throughout its life until and unless some external force is applied on it. Otherwise, tell me what is the force which is driving the rotation of Earth? Revolution, ठीक है, Earth's gravitational force is making it to revolve around it. But how about rotatory motion? ठीक है, so rotatory motion is something, अगर Earth जो है, if it was not rotating, then it will not rotate. No? It will keep on moving around the sun like that only, right? For example, moon, you know, moon rotation is very, very slow. And thus its rotation is also not increasing, not changing, okay, because of first law of motion. ठीक है, रोटेटरी मोशन विल नॉट change or its speed will not increase or decrease until some force is applied on it. So answer is not no, but yes. Any doubt in this?
No, sir.
सर फिर से एक बार एक्सप्लेन कर दीजिए.
हाँ जी. So Naman question was, does Newton's first law of motion apply on rotatory motion? That means anything which is not rotating or which is rotating at a high speed will either not rotate or will continue to rotate at the same speed for eternity until some force is applied on it, right? So answer is yes. Anything which
Okay,
is
sir.
rotating at very high speed. Now if I'll take a top, है ना, top को अगर मैं spin कर रहा हूँ बेटा, so this top will keep on spinning throughout its life. ठीक है, ये throughout its life spin करता रहेगा. Now thing is, there is a friction between the surface and the top needle, and that friction is generating some heat, so some force is getting, frictional force is applied on it, and thus it's stopping down. But if I'll put this top in space, it will keep on rotating.
Sir, but
Sir,
will the top remain in the same direction throughout? It will be rotating, like the
It will
period
maintain the same
will it
direction
be in the same
also.
direction only?
हाँ जी, it will maintain the same direction. Earth is nothing but a top. ठीक है, Earth is nothing but a top. तो ये जो टॉप की डायरेक्शन यहाँ पर ऐसे है, तो यहाँ पर जब अर्थ आएगी तो उसकी डायरेक्शन ऐसे ही होगी. इट्स डायरेक्शन विल नॉट चेंज लाइक दिस, वो चेंज नहीं होगी. नथिंग इज, अर्थ का जो टॉप है, ठीक है, वो जो टॉप है दैट इज रिगलिंग, वो ऐसे ऐसे रिगल भी कर रहा है. ठीक है, आई विल नॉट गो इनटू दैट, दैट्स प्रिसेशन ऑफ एक्सिस, आप बाद में चेक कर सकते हैं. बट टॉप की जो रोटेशन डायरेक्शन है दैट विल आल्सो रिमेन सेम.
सर अर्थ रिवॉल्व तो ग्रेविटेशन फोर्स की वजह से करती है, रोटेट क्यों कर रही है?
Earth is not rotating because of gravitational pull of sun. It's rotating because in the starting formation, right, it developed that rotational speed and it's maintaining that. So
Okay,
Jupiter
sir.
is rotating, Jupiter is very, very big and it's rotating at fastest speed, है ना? It completes one rotation in 10 hours only. So it has nothing to do with gravitational pull or something. Okay. So if you talk about satellite, ठीक है, तो satellites जो है they are moving in circular direction as a result of forces acting on it. ठीक है, तो satellite has got its own momentum in this direction. Earth's gravitational force is pulling it down. So if gravitational force is not there, it will just escape the Earth in a linear way. But because of this, the resultant is ending up here, and this is why the satellite keeps on moving in circular motion. Same goes for moon. Chat box में आंसर करेंगे बेटा. I am expecting 5 wrong answer. And everyone please participate. Revision classes can be fun only if there is more and more participation is there. Impressive. First correct answer by Parthuso, Naman, Siddhant, Manol. Vedant, Raghuvansh, Garv. Okay, teacher is going to lose all correct answers till now. So 3, 6, 7, 8, 9, 10. 10 on 10. Need 20 answers. Others, Mayank, Devika, Tisha. Impressive. Devika, Anya, Edvik. Okay, teacher is a loser here. We have got 15 out of 15. So answer is 0 Newton. Okay. Why 0 Newton? Because the object, to keep object moving with same velocity. ठीक है, so object की अगर हमें velocity change ही नहीं करनी है, so we don't need any force. ठीक है, if they are sending a spacecraft in space, ठीक है, जब spacecraft बेटा space में जा रहा है, So you need energy for it to escape the Earth's atmosphere. ठीक है? So 95% fuel spacecraft को यहाँ से यहाँ तक लाने में लगता है. Then they give 2% fuel to give it a push. After that, the spacecraft does not use any fuel to travel millions of miles. There is no friction, and thus there is no change in velocity. It keeps on moving, same direction, same speed throughout its life. So 2% fuel is if you have to change the direction. So in that case, they have got air blowers are there in the front part. So if this is blowing this side, spacecraft will tilt slightly on the other side. Newton's first law of motion is also called as
Law of inertia.
law of inertia. Very good. Okay, let's talk about this. So inertia is the property due to which any object resists a change in its state of motion. Okay? Property because of which any object resists change in its motion. Change in its motion means it will resist three things. Those three things are, it will resist the change in motion of rest. At rest, it likes to remain at rest. Okay? Change in the motion itself, that is speed or velocity, and change in the direction. So that is inertia of direction. Anything going in no direction will tend to go in that direction until unless some force is applied on it. It will resist any change in that direction. Okay? Fourth one is inertia of rotation. Inertia of rotation. A body will resist the total change in the momentum of rotation. Okay, let's see here. So what can you make a statement seeing this picture?
So inertia is directly proportional to mass.
Very good. More the mass, more the inertia, more is the resistance to any change. Hanji, one line. This is because of
Inertia motion.
Inertia of rest.
ना
Inertia of motion.
Of motion.
Hanji, Vedant, आप बोलो inertia of motion कैसे है? What actually may have happened here, Vedant?
तो चल रहा था और एकदम से रुका तो वो वाला जो ब्रेक है वो था तो
हाँ जी, तो थोड़ा सा ना nouns भी use करो साथ में. So what Vedant is saying, sir, when the truck was moving, ठीक है, the cargo inside was also moving. So suddenly when the truck applied the brake, truck came to the rest, but the cargo inside it, that was still in motion, right? So that motion led it cargo to keep moving and it struck the toe part of the truck. Very good. Right? This is again
Inertia of rest.
Inertia of rest.
of rest. This is inertia of
Motion.
motion. Cycle, it was coming, it was moving at great speed, and suddenly it applied brake, but the rider, he was still in motion, right? And this is what resulted into. This is
Inertia of rest.
Inertia of rest.
inertia of rest. You know, when you are beating the mat, the dust particle mat goes into motion, but the dust particle which were at rest, they remains at rest and they will basically come out from the mat. So it's not the dust particle which comes into motion, but the mat which comes into motion, and dust particles are left out. This is
Inertia of rest.
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 Tree was at rest and fruits were at rest. So when we shake the tree, the fruit, they resisted the motion, and as they resisted the motion, they followed from the tree. So raise your hand who wants to explain this. Question is, अगर आप इसको two strings are there है ना, if you are pulling it slowly, if you pull it slowly, then what's going to happen is the downward string which will break down. Sorry, upward string will break down, and if you are pulling it with a jerk, then the lower string will break down. So why that's happening? अगर आप slowly pull करेंगे, slowly, then upper string
Sir,
and will suddenly the lower string will break. Both the strings are of same material and same length. हाँ जी.
सर सडनली खींचने से जो वो मास है लटका हुआ उसका इनर्शिया प्रिवेंट करेगा उसको हिलने से और स्ट्रिंग जो है कमजोर होने की वजह से टूट जाएगी पर अगर धीरे धीरे खींचेंगे तो इनर्शिया उस केस में लगेगा ही नहीं क्योंकि धीरे खींचने से फोर्स लगेगा नहीं जिसकी वजह से धीरे धीरे स्ट्रेच होने की वजह से ऊपर वाली स्ट्रिंग टूट जाएगी.
But upper string ही क्यों टूटेगी when you are pulling slowly? Lower string भी तो टूट सकती है.
तो जो कि उसमें जो मास है वो तो ऑब्वियसली एक नीचे की तरफ फोर्स लगा ही रहा है जो वो
Very
उसके
good.
इक्वल है mg के इक्वल.
Very good. Edvic, you like to add something in this? Okay, so what Naman is saying is, sir, if you are pulling it slowly, हाँ जी बोलो.
यस सर जब हम स्लोली पुल करेंगे तो सर जो हमारा पुल करने का वेट है एंड जो सर बॉल का वेट है वो दोनों एड अप हो जाएंगे.
Impressive, very good.
एंड सर जब सडनली पुल करेंगे तो सर वो इनर्शिया रेस्ट में होगा वो तो फिर वो सर साथ में नहीं आएगा सिर्फ स्ट्रिंग आएगा नीचे.
Very good. ठीक है? Because of inertia of rest, when you are giving it a sudden pull or a jerk, the force does not get transferred to the upper string. Force जो है वो ऊपर वाली string पे जाएगा ही नहीं. Because of inertia of rest, this string is one which will get pulled, right? Before the force actually get transferred to the upper string. Okay, so that's what is playing role here is the inertia of rest. Okay, it goes with this box also. If this box is there, right, if you are giving it a sudden jerk, the string or the rope will break down. Chat box, 2 wrong answers I'm expecting. If a bus is moving at uniform speed of 100 km per hour, I've tossed a coin. So where the coin will land? Coin will land back to my hand, that is A. Coin will land at point B or at point C. Where exactly coin will land with reference to my hand? वो वापस मेरे hand पर आएगा या hand से पहले या बाद में? So I have already got wrong answers here. Okay, so these wrong answers are by Manol, Vedant, Naman, Mayank, and Devika. Okay, so what's happening here is this 100 km per hour is the speed of bus, and thus is speed of this person, and thus is the speed of the coin which is in his hand. ठीक है, 100 km per hour बेटा सभी की speed है. So what's happening is when the coin is being tossed, the coin, this person hand is moving at 100 km per hour. ये जो coin toss हुआ है ये ऊपर तो जा रहा है, साथ में it is also moving 100 km per hour in this direction. So if you have tossed it vertically up, अगर आपने इसको vertically up toss किया है, then it will land back in your hand at the same time. It will not land in front or back of the hand. It will land exactly in your hand.
सर अगर एकदम से ब्रेक लग गए तो?
अगर एकदम से ब्रेक लगा तो ब्रेक की वजह से you will stop. But coin जो है वो बस के कांटेक्ट में नहीं है, डायरेक्ट कांटेक्ट में. So there is no force on the coin, and thus coin is still moving at 100 km per hour. So coin will fall ahead of you.
Okay.
और सर एक्सेलरेटेड मोशन में
अगर accelerated motion है, so when you toss the coin, your speed is still increasing, right? Because it's accelerated motion, you are in contact with the bus, but that coin is now no more in contact with the bus. तो अगर आपकी स्पीड जो कॉइन को टॉस करते हुए 10 मीटर पर सेकेंड थी, तो कॉइन की स्पीड 10 मीटर पर सेकेंड, but after few fraction of seconds your speed has become 12 meter per second, but coin is still at 10 meter per second. So you are moving faster, coin is slow, so coin may hit your face actually, instead of point A, coin will land up at point B, or may fall behind your head or behind your seat, depending on how much acceleration is there. So अगर ब्रेक लगेगा तो पॉइंट सी, ठीक है, अगर एक्सेलरेशन है तो पॉइंट बी, or otherwise constant uniform motion, it is point A. Agreed? Next one. So raise your hand. You have to raise your hand, don't speak like this. So question is, you are standing on a bus, and bus driver, when he starts with the jerk, or if you are standing in a metro, you will experience that you are falling backward. So why that's happening? I need, out of 2, I'll give you a score. Let's see who is explaining it. Okay, Sarthak.
Sir, in the person A who's first, sir, his hands and sir, his legs both are in direct contact with the bus. So, sir, when the bus driver is accelerating the bus, both of them will accelerate, but in B, the person is not contact with the upper part of the body, and only the lower part is accelerating, but the upper part is in rest, so it resisting.
Okay, 1 minute, Sarthak, question is, they are not two persons are there, this is when the bus is at rest. Okay, this person was not holding that pillar tightly, so this is when it started moving suddenly, he felt backward. ठीक है, तो पीछे की तरफ गिरा. तो why that has happened, I'll give you maybe 1 out of 2. Edwick.
सर उसके जो पैर थे वो बस से साथ कनेक्टेड थे. सर जब बस आगे चली उसके पैर भी साथ में चले गए, और अपर बॉडी इनर्शिया ऑफ रेस्ट में थी, इसलिए सर वो पीछे ही रहेगी, वो कनेक्टेड नहीं थी, इसलिए पीछे रहेगी सर.
Impressive. I'll give you 2 out of 2. ठीक है, so the person's leg or person's shoes, they were in contact with the bus, and as the bus moved suddenly, the leg, because of friction, they had force on the leg, and they also moved with the bus suddenly, but the upper body was at rest, and thus it fall backward. Right, this is inertia of direction is there. So when the bus is taking a sudden turn, you tend to fall outward. That's because of inertia of direction. You like to maintain the straight direction, but bus is taking a turn, so you have to take a turn because of this. Bus is trying to move in this direction, so your body will fall outward. Your body will fall outward. So why rope walkers carry big stick? हाँ जी, स्पीक आउट प्लीज.
सर डायरेक्शन देखने के लिए जब वो जाते हैं.
डायरेक्शन देखने के लिए
सर मतलब सर मैं एक्सप्लेन नहीं कर पा रहा हूँ.
Okay, anyone else? It's not for checking any direction. No, वो एक simple straight rope है. They have to walk on that rope. हाँ जी, anyone? That's.
So,
हाँ जी, बोलो.
so maybe to balance themselves, sir, agar so if there's a very high wind flowing, so they don't go in the direction of the wind just to maintain their body straight in the line.
To go in direction of wind, I will like to go in the direction in which rope is there. Wind की direction में जाएंगे तो rope से गिर जाएंगे. और balance बनाना is more easier if you are not carrying any weight. This stick is such a long stick, है ना, उसके साथ बैलेंस बनाना it will be more difficult.
सर हाँ जी बोलो. Sir, maybe to maintain inertia of direction.
Okay, it's not inertia of direction, it
Sir,
is
inertia of rotation.
inertia of rotation. Very good, Raghuvansh. Okay, it is very difficult to rotate something which has got a mass spread it out. ठीक है, if I will say, अगर बेटा मैंने आपको ये एक डंबल दिया है ना, this is, let's say, is having a mass of 20 kg each. ठीक है, आई एम जस्ट आस्किंग यू टू रोटेट इट, है ना, 180 डिग्री रोटेट करना है. ठीक है, पॉइंट ए एंड बी. सो आप इसको उठाएंगे एंड यू विल रोटेट इट. इट वोंट बी अ वेरी टफ जॉब एंड यू विल बी एबल टू रोटेट इट इजिली. ठीक है, सो दिस इज बी एंड ए. बट सेम थिंग, अगर मैंने सेम वेट है ना, इफ आई मेड इट लाइक दिस एंड आई आस्क यू टू रोटेट, you will need 2 persons or 4 persons to rotate this. ठीक है, दिस इज इनर्शिया ऑफ रोटेशन. ठीक है, अगर आपका जो मास है, ठीक है, इट इज डिस्ट्रीब्यूटेड अवे फ्रॉम द एक्सिस, then it is more difficult to rotate the object. And that's how the person who is a rope walker, okay, when he is carrying this, now because of this difficulty in rotation, he will walk in the straight line. ठीक है, स्ट्रेट लाइन में क्यों वॉक करेगा? क्योंकि लेफ्ट राइट रोटेट ही नहीं हो रहा है. सो ही इज नॉट गोइंग टू चेंज इट्स डायरेक्शन ना, इट विल मेंटेन द सेम डायरेक्शन. स्पेशली अगर कोई ब्लाइंड फोल्डेडली वॉक करता है रोप पर, देन दे डेफिनेटली कैरी दिस लॉन्ग रोड्स.
सर इनका सेम वेट होता है एंड्स में?
हाँ, यहाँ पर सेम वेट है बेटा एंड में, बट अगर ब्लाइंड फोल्डेड है तो दे हैव एक्स्ट्रा वेट इन द एंड्स. Okay, this is rotational inertia, not in our syllabus, just to introduce, you know, what is rotational inertia. Okay, this question is very interesting. I've taken it once before. Let's take it again. Please read it.
सर चैट में आंसर करना है?
हाँ जी. So anyone who has not followed the question? Now this thing is, you know, easy task. So this I will answer it. The brakes are applied suddenly to stop the train. Okay. So will the balls start rolling? Yes, because of inertia of motion. The balls were in motion and the train came to rest. So ball will remain in motion, and thus answer is yes. Next is, if so, in which direction? Of course, they will move in the same direction in which they were moving before. So that I will say in the forward direction, है ना, जहां पर जिस direction में train was moving in the same direction. Which ball will move with greater speed? So when they have started moving, they will move with a certain velocity, right? So which will move with a greater velocity, greater speed? And which ball will move greater distance? कौन ज्यादा स्पीड से स्टार्ट करेगी मूव करना और ज्यादा डिस्टेंस? So I'll name this hollow one as A and the solid one as P.
तो मैंने एक भेजा आंसर।
Okay, let's see. Very good path Huso. But आपने पहले का आंसर नहीं दिया. Which ball will move with greater speed? Ariman wrong. Edwick wrong. And Siddhant correct. Okay, a lot of answers are there, है ना? Not possible to check each one. Let's see here, please. नब सार्थक आपका गलत है। चैट बॉक्स में क्यों नहीं आंसर कर रहे हो सार्थक?
सर अभी चल नहीं रहा था चैट बॉक्स में, इसलिए
अच्छा
WhatsApp पर।
Okay, no issues. So you can answer on WhatsApp.
Sir, is my answer correct?
One minute, beta. Okay. नहीं, Parthu, so it's wrong. Let's see here. So which ball is going to move with greater speed? Parthu, so आप बताओ बेटा मेरे को। पहला तो ये जो है ये किस स्पीड से मूव करेंगी और क्यों मूव करेंगी पहले ये बता दो। अच्छा हाँ जी Parthu, so why they will move? Sir, because of, चलो सार्थक आप बताओ।
Sir, because of inertia of motion.
इनर्शिया ऑफ मोशन है ना, जो ट्रेन है और ट्रेन के अंदर जो बॉल्स थी बोथ वर मूविंग इन द सेम डायरेक्शन, सडनली द ट्रेन केम टू अ हॉल्ट, सो द बॉल which were moving in a certain direction will keep on moving in the same direction and with same velocity. ठीक है, जो उनकी इनिशियल वेलोसिटी थी दैट इज जो ट्रेन की वेलोसिटी थी, है ना, so ball will keep on moving with the same velocity as of was train before applying the brake. So both the balls are going to move with the same velocity. दोनों same velocity से move करना शुरू करेंगी, right? अब ये दोनों बॉल जो है थोड़ी देर बाद, है ना, after some times they will come to a halt. They will stop moving. Why they will stop moving?
तो फ्रिक्शन।
Because of frictional force. ठीक है, फ्रिक्शनल फोर्स दोनों पर कितना लग रहा है? सेम लग रहा है, बिकॉज दे आर ऑन सेम सरफेस, दे आर मेड अप ऑफ सेम मटेरियल। ठीक है, बट जो हैवियर बॉल है, दैट हैवियर बॉल इज हैविंग हायर व्हाट?
Mass.
इनर्शिया। ठीक है, हायर इनर्शिया मींस इट विल बी मोर डिफिकल्ट टू चेंज इट्स मोमेंटम और टू चेंज इट्स वेलोसिटी. More difficult means it will be more difficult to stop it, and thus the heavier ball will cover greater distance. So second part का answer था both will start moving with same speed, and last part answer was which ball will move greater distance? The heavier ball will move greater distance because it will have greater inertia of motion, and thus it will be more difficult to stop it. Understood everyone?
Yes sir.
Yes sir.
Sir, which ball will move with the greatest speed का क्या explanation था?
Which ball will move with greater speed? Okay, they will move because of inertia of motion, right? So they will move with the same initial velocity by which they were moving before, and both were having same initial velocity, so they will move with same velocity when the brake is applied.
सर वो ट्रेन की जब ब्रेक लगाने से पहले भी वो मोशन में ही थे?
नहीं,
तो सर जैसे आपने कहा कि ग्रेटर जो हेवियर
देखो
बॉल
जब
थी।
ट्रेन जो है 20 मीटर पर सेकंड से चल रही है, both the balls they are on the surface, they are not moving, ठीक है, but they are moving with the train. Now when the train will stop, अगर ट्रेन ने सडनली ब्रेक लगाई है तो बॉल they were moving at 20 meter per second with reference to a tree outside, and thus they will keep on moving at 20 meter per second with reference to tree outside. So both will have same initial velocity.
Okay, sir.
ठीक है, तो इस बॉल की जगह जो है आपने एक हाथी को रखा ट्रेन में, बट स्केट्स पे ना कर, so that elephant will also move at 20 meter per second. Basically they have not started moving, its only thing is they have not stopped. ट्रेन रुक गई है, बट वो जो मूव कर रहे थे पहले, they are still moving at same speed of 20 meter per second. Answer is ABC. Siddhant is wrong.
सर एक और बार भेज सकते हैं?
नहीं भाई, ऑप्शन ही 3 है, तो आपने यहाँ से जो है बॉल को ड्रॉप किया है, यहाँ पर रेजर था, so once ball reaches at this point, this razor will cut the string. String cut होते ही जो है बॉल की मोशन कैसा होगा, that's you have to tell. Very good, first correct answer by Mayank. Aryaman Som, Advik Vedant. Naman is wrong. Raghuvansh super wrong. Daksh also super wrong. Anya is wrong. Trisha correct. Amitos correct. Shobhit correct. Gulf is wrong.
सर मेरा करेक्ट है।
सार्थक इस्तेवाल बोल रहा है कि सर कुछ और इमोशन होगा। सार्थक आप बताओ बेटा कैसे जाएगा वो हवा में?
सर बी टाइप होगा लेकिन वो कर्व नहीं होगा।
बी टाइप होगा, कर्व नहीं होगा, तो वो तो ये हो गया, और कर्व नहीं होगा मतलब आप कह रहे हो ऐसे जाएगा?
यस सर।
ओके चलो जी, ये डी ऑप्शन दिया है सार्थक ने। Those who agree with him can give D. ठीक है, डी ऑप्शन इज दिस इज डी ऑप्शन। Okay, Shreya correct, Devika wrong, Prisha wrong. Okay, so more than 50% are wrong, है ना? थोड़ा सा ध्यान देंगे। पहला तो
सर मेरा करेक्ट था।
who was this? Amitos correct. So after Amitos, Kabir correct. Very good, Kabir. Okay, let's see here. So when you have dropped this, यहाँ से बेटा जब उसको ड्रॉप किया तो वो यहाँ पर आया, है ना? बॉल यहाँ पर आई है, अगर स्ट्रिंग नहीं टूटेगी तो बॉल वापस यहाँ पर जाएगी, ठीक है? जब स्ट्रिंग टूट गई है, ठीक है, तो इस पॉइंट पर बिफोर द स्ट्रिंग एक्चुअली ब्रोक डाउन, ठीक है, तो इस बॉल का जो मोशन है वो किस डायरेक्शन में है? दिस बॉल वाज मूविंग इन दिस डायरेक्शन, वो इस डायरेक्शन में मूव कर रही थी, ठीक है, बट इसके ऊपर एक फोर्स, स्ट्रिंग का टेंशन फोर्स लग रहा था जो इसको ऊपर की तरफ पुल कर रहा था। बट जैसे ही स्ट्रिंग टूट गई, वंस द स्ट्रिंग हैज ब्रोकन डाउन, ठीक है, स्ट्रिंग के ब्रोकन डाउन होते ही देयर इज नो एक्सटर्नल फोर्स, इन एब्सेंस ऑफ एनी एक्सटर्नल फोर्स दिस बॉल वाज सपोज्ड टू मूव इन सेम डायरेक्शन, स्ट्रेट डायरेक्शन, वो ऐसे जानी चाहिए थी, but at same time there is a gravitational force acting on it, so this ball is going to go down also, ठीक है। सो ये जो ड्रॉप डाउन है ये तो बिल्कुल ही गलत है, ये ड्रॉप डाउन बोल रहा है देयर इज नो लीनियर मोशन, सिर्फ और सिर्फ ग्रेविटेशनल फोर्स लग रहा है, सो दैट्स रॉन्ग, ठीक है। सी वाला पोर्शन क्या बोल रहा है कि सर ये पहले थोड़ा सा ऊपर जाएगा, ऊपर क्यों जाएगा? इसके ऊपर सिर्फ दो चीजें एप्लीकेबल हो रही हैं, क्या चीज कि एक तो इसका मोशन इस डायरेक्शन में था, दूसरा इसके ऊपर ग्रेविटेशनल फोर्स इस डायरेक्शन में लग रहा है, तो इन दोनों चीजों को देखें तो ये ऊपर जाने के लिए कोई फोर्स जब था ही नहीं उसके ऊपर, ठीक है, इट विल नॉट गो अप, और ये हमने स्टार्टिंग में डिस्कस किया था, देयर इज नो इनर्शिया ऑफ रेवोल्यूशन और सर्कुलर मोशन, ठीक है, ऐसा कोई नहीं है हमारे पास कि सर्कुलर मोशन में बॉडी जो है सर्कुलर मोशन में ही मूव करती रहेगी, नो, ठीक है,
सर
थिंग इज रॉन्ग। हाँ जी
सर, पर इस केस में ये बी वाला ऑप्शन तभी पॉसिबल होगा जब स्ट्रिंग जो कट रही है उसका टाइम बहुत ही मिनिमल हो, क्योंकि वरना अगर स्ट्रिंग काटने में टाइम लेगी तो वो जो पेंडुलम की तरह बॉल होगा वो ऊपर की तरफ टेंड करेगा मूव करने के लिए।
अच्छा, अब देखो आप कितनी, है ना, इम्प्रैक्टिकल बातें कर रहे हो बेटा, ठीक है, ये अगर आप देखेंगे तो ये जो रेजर है और ये है ना, दिस इज एट द सेम हाइट। अगर आप कह रहे हो कि सर यहाँ पर ये आया और उसके बाद जो है स्ट्रिंग जो है अपना आधा एक घंटा जो है वो गाजर मूली काटने में जैसे लगता है वैसे टाइम लेगा, और फिर ये यहाँ पर ये बॉल है, अगर ये टाइम लेगा भी तो ये बॉल यहाँ पर ऊपर ऐसे चल जाएगी, है ना, तो वो कुछ और ही मोशन हो जाएगा, बट ये वाला मोशन फिर भी नहीं आएगा हमारे पास।
ओके सर।
राइट। अब यहाँ पर जो है व्हेन द स्ट्रिंग इज कटिंग इट, ठीक है, तो सार्थक बोल रहा है कि सर मोशन तो ऐसे स्ट्रेट लाइन में होना चाहिए, तो बेटा वो मोशन स्ट्रेट लाइन में नहीं होगा, ठीक है। व्हेन यू आर ड्रॉपिंग अ बॉल, अगर किसी बॉल को आप थ्रो कर रहे हैं, तो व्हाट्स हैपनिंग इज ये जो हॉरिजॉन्टल है, ठीक है, हॉरिजॉन्टल वेलोसिटी तो कांस्टेंट है, ये चेंज नहीं कर रही है, बट वर्टिकल वेलोसिटी जो है वो वर्टिकली एक्सिलरेट हो रहा है, फोर्स लग रहा है तो वर्टिकली एक्सिलरेट हो रहा है, तो इवेंचुअली स्टार्टिंग में कर्व जो है वो आपका ये आएगा, फिर उसके बाद हॉरिजॉन्टल मोशन एंड वर्टिकली एक्सिलरेट हो रहा था तो वेलोसिटी ज्यादा हो गई, है ना, फिर ये मोशन ये हो गया, फिर वापस हॉरिजॉन्टली तो सेम है वेलोसिटी, कोई फोर्स लग ही नहीं रहा है, वर्टिकली जो है वो एक्सिलरेट हो रहा है तो वो इंक्रीज हो रही है, ठीक है, तो ये ऐसे आ गया, तो ये स्ट्रेट लाइन नहीं बन रहा है, मैंने इसको ब्रेक डाउन किया है फॉर 1 सेकेंड इंटरवल, बट ये फ्रैक्शन ऑफ सेकेंड के उसमें अगर आप वर्कआउट करेंगे तो ये जो मोशन बनेगा सार्थक, ये स्ट्रेट लाइन नहीं होगा बेटा, ये पैराबोला बनेगा।
ओके सर।
ठीक है,
Sir, I have a doubt.
तो दिस इज व्हाट द मोशन विल बी। हाँ जी बेटा।
सर अगर हम किसी चीज को वैक्यूम चेम्बर में डालते हैं तो सर उसका बस एयर रेजिस्टेंस जाता है कि ग्रेविटी भी जाती है?
ओके, वेरी गुड डाउट, सिर्फ एयर रेजिस्टेंस जाएगा बेटा, ग्रेविटी इज, ग्रेविटेशनल फोर्स इज इंडिपेंडेंट ऑफ द मीडियम, ठीक है। अगर आपने दो ऑब्जेक्ट्स के बीच में स्पेस रखा या वैक्यूम किया या एयर रखी या वाटर रखा या फिर लेट्स से 8 इंचेस की थिक स्टील प्लेट रखी, that will not make any difference at all in the gravitational force between those two objects, ठीक है, gravitational force is independent of the medium।
Okay sir।
Okay। Answer this, A, B or C. Before you are answering it, please raise your hand, everyone. Attendance, raise your hand. Raise your hand. So Siddhant is excused. Others, please raise it. Okay, let's see here. Daksh is incorrect, and rest all are correct. Sarthak, Istawal, and Raghuvansh are incorrect. So they are correct. Aditya is incorrect. Trisha incorrect. Okay, Aditya, help me out, beta. Why you are saying, sir, it will follow A?
सर वो इनर्शिया ऑफ डायरेक्शन की वजह से नहीं होएगा।
हाँ, इनर्शिया ऑफ डायरेक्शन, बट यहाँ पर अगर आप बात करेंगे तो ये देखो, ये यहाँ पर अगर मैं पॉइंट ए की एक्स की बात करूं तो वो यहाँ पर इस डायरेक्शन में था, अगर मैं यहाँ पर बात करूं तो वो इस डायरेक्शन में मूव कर रहा था, पॉइंट ए की बात करूं तो इस डायरेक्शन में मूव कर रहा है, तो वो तो डायरेक्शन चेंज हो रही है। एनीथिंग मूविंग इन सर्कुलर डायरेक्शन इज एक्चुअली चेंजिंग इट्स डायरेक्शन एवरी फ्रैक्शन ऑफ सेकेंड, वो कॉन्टिन्यूसली डायरेक्शन चेंज हो रही है उसमें तो। और इनर्शिया ऑफ डायरेक्शन क्या बोलता है, इट विल मेंटेन इट्स डायरेक्शन नॉट इट्स सर्कुलर मोशन, ठीक है। सो पॉइंट ए से बाहर निकलने पर, पॉइंट एक्स से जैसे ही वो बाहर निकलेगा उसके ऊपर कोई फोर्स नहीं एक्ट हो रहा है, पॉइंट ए से व्हेन इट इज, यू आर चेकिंग इट एट पॉइंट ए, it's moving in this direction, it will keep on moving in this direction only. So right answer is B and not A. To go in A, it still needs some external force. Okay? That external force is absent here. So that bullet will maintain its velocity and its direction. And direction at X is straight direction, not curved. Right, right. Next one. So define force as per Newton's first law of motion. ठीक है, फोर्स हमने वो तो किया है, छोटी सी बचपन में डेफिनेशन की थी, फोर्स इज अ पुश और अ पुल, बट आई एम नॉट हैप्पी विद दैट. न्यूटन्स फर्स्ट लॉ ऑफ मोशन के रिगार्डिंग व्हाट कैन यू से, व्हाट इज फोर्स?
So force is an influence that causes a body to move or a moving body to stop.
Allo ji, how about I am applying a force and the body is changing its direction?
Sir, may I answer?
हाँ जी.
Sir, a force is an influence that causes a body to accelerate in any direction.
Do you need to write in any direction?
That causes the body to accelerate.
हाँ जी, ठीक है. Force is something that causes acceleration in a body. ठीक है, और ये जो force जब हम बोल रहे हैं, we are talking about unbalanced force. ठीक है, so unbalanced force is something which causes acceleration in a body, then that is your force. Anything which causes acceleration in the body. In absence of force, body will not accelerate. In presence of force, body will definitely accelerate. ठीक है, so first law of motion is saying same thing कि वो acceleration zero होगा. ठीक है, if there is no external force. So what is external force? External force is something which causes acceleration in a body. Right, agreed on this? So let's take now this force which is causing acceleration. Question is कितना force कितनी acceleration देगा? So for that Newton had written down second law of motion. Right, second law of motion. Anyone, what is second law of motion? Raise your hand. हाँ जी अमितोष. Okay, anyone speak it out please? Parth also speak out please. Vedant.
The rate of change of momentum is equal to the applied and balanced force.
Okay, rate of change of momentum of a body is directly proportional to balanced force. ठीक है, वो directly proportional में that constant Newton took it as 1. So force is rate of change of momentum. Rate means per second how much the momentum is changing. So that is time period will be in division, and change of momentum. ठीक है, P is for momentum. So this is change of momentum is mass into velocity upon time period. Now mass is constant, change in velocity is v minus u upon t. And this rate of change of velocity is what you call as acceleration. So force is mass into acceleration. This is what is Newton's second law of motion.
सर इसके न्यूमेरिकल्स भी कराओगे आप?
हाँ जी बिल्कुल. ठीक है, another definition you can say is force equals, यहीं से definition बनेगी, force equals mass times acceleration. That's Newton's second law of motion. What
Sir.
Vedant gave is what is official definition. So we'll expect you to write that definition whenever the question arises. Ready? Let's take one or two numericals here before we end the session. हाँ जी.
सर मास इन मोशन को क्या होता है?
दोबारा बोलो.
सर हैंडआउट में भी लिखा है सर सेकंड लॉ के नीचे मास इन मोशन, उसका क्या मतलब है?
Mass in motion means mass which is moving.
अच्छा ओके सर.
Okay. What force would be needed to produce an acceleration of 5 meter per second square in a cycle of mass 800 grams? I'm expecting 2 mistakes. Prove me wrong. ठीक है, 20 answers, 2 mistakes. That's the challenge. So correct Anya first, Amitos, Raghuvansh, 3 correct. Let's see, more to come here. 4th Curve, 5th Siddhant, 6th Vedant, Prisha, all correct. Okay, very good. Out of 8, 8 out of 8, 10 correct. 1 wrong. श्रेया आपका गलत हो गया है. So 13 answers. 14th Tanvi wrong. Okay, so I've got 2 wrong already. So that was the challenge. Hirvita correct, Aryaman correct, and third Harshdeep wrong. Okay, let's see here beta. So when I'm talking about force आप जो presentation है वो भी ऐसी रखेंगे. Force is mass into acceleration. Then you will say mass is 800 grams, which is 0.8 kg. ठीक है. Units जो है आपको SI units लेनी है. So acceleration is 5 meter per second square. I have absolutely no issue with this. So force is 5 into 0.8. ठीक है. This is kg, this is meter per second square. So either you can write kg meter per second square, or you will say this is 4 Newton. अगर आपने 4 Newton ऐसे लिखा है, this is wrong. Newton symbol is capital N. Any doubt, anyone?
No.
Okay, simple question though. Calculate force required to change the speed of 1000 kg mass car from 10 meter per second to 40 meter per second. ठीक है, इस चीज को चेंज कर लेते हैं. आई एम एक्सपेक्टिंग 10 wrong answers now. From 80 meter per second to rest. चलो जी, आई एम एक्सपेक्टिंग 10 wrong answers. Prove me wrong. Very good, impressive Siddhant. First correct. Raghuvansh second.
सर वो कैप्स लॉक ऑफ
हाँ नहीं
ऑन हो
ठीक
गया
है. I am
फिर।
giving it correct. Daksh correct. Okay, 10 wrong. First is Naman wrong, Tanvi wrong, Amito's wrong. 3 out of 6 wrong. And Vedant, Anya, Garv, all correct. Beta fatafat hai na? Make it fast. Fourth, Trisha is wrong, Aditya wrong. 5 wrong answers. Rest are scared or still calculating. Aryaman Som wrong. Hirvita, congratulations, correct. Prisha is wrong. चलो 50% correct, 50% wrong. देख लेते हैं जिनके wrong है. They are losing half a mark out of 2. Why they are losing half? Let's see here. Sarthak is still correct. So we have got force is equals to mass into acceleration. So you'll say m is mass, which is 1000 kg. Right? A is acceleration, which is v minus u by t, which is 0 minus 80 by 10, which is minus 8 meter per second square. So force is 1000 into minus 8. This is minus 8000 Newton. आपने अगर if you have not written down negative sign, then you are losing half a mark. So be very careful. This force was doing negative job by reducing the velocity instead of increasing it. So negative sign denotes it's a vector quantity. Force is doing a negative work here. Okay, let's end the session here. Tomorrow will be laws of motion will continue from here, and we'll take third law also.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir. Have a nice day.
Thank you.
Bye
Thank you, sir.
bye.
Bye, sir. Good day.
Thank you, sir. Bye, sir.